This video is going to show you how to build, flash, and set up a debug session for the BootMIPS project on a multiboard with an interactive core in the FPGA. So the first thing we're going to do is check the properties. If we look at the behavior, under build we should have interactive Malta RAM, and under clean interactive. These are actually the build targets. I'll show you where we got those from. We got those from the make file here. If you look at the make file, you can see we get down to the interactive. You can see interactive Malta RAM, which is what we're building for. Okay, we'll close that and we'll do a build. And you can see the build output coming in this window right here. Okay, the build's complete. We look in the interactive directory and we can see the output of the build files. We have a debug ASM file, we have the map files, we have bin files. We're actually going to be using the Malta RAM bin file to flash into the flash on the Malta board. And I'll show you that in the next step. So here's a Malta board, and you can see we've already powered it up. Now what I'm hooking up here is the debug port. So the debug port is actually underneath the daughter board. To program the flash, I'm going to use the Navigator console. To start the Navigator console, I first have to actually create a script to start it for the interactive board. So I selected the Start Navigator Console and select Script from the Windows menu, and this is what I get. I get the Select Script dialog, and I choose the interactive tickle and Setup. Now what I need to do is I need to set this up for 4 CPUs, since that's what my FPGA has in it. Everything else is correct. I'm going to name it C4.tcl and then run the script. So we can see that the device booted, all the cores and all the VPEs booted, and all of them were set up for the debug session. So now we're going to issue some flash commands. Set up the flash device. Clear the configuration. We're going to set the memory range. Going to erase first sector. Oops, so we got to halt the target first. Now we'll erase that first sector, and we're going to erase the second sector. Now we're going to load the bin file that we built. And the load is complete. So next we're going to set up the launch dialogues that we could use for launching the debugger. So the first thing we're going to do is select Debug Configurations, and we're going to double click on the MIPS ICS application, and we're going to name it C0V0 for the first one. We can see that it is properly set to the ELF file we want. I'm going to click on the debugger. We're going to change the launch preset to debug boot code. We're not going to download code. We can see that it's still set up for little endian. We scan for probes, and we actually scanned for one already. This is the proper probe. We're going to select a configuration tickle file, and we're properly set up for C0V0 by default on this one. And we're going to click Apply. We're just going to duplicate this, and we're going to change the name. This time it's going to be C1. We're going to change the launch preset to Advanced. We're going to change it to no reset since the first CPU is actually going to do the reset. We're going to give it a custom symbol, PC in this case. We're going to stop at the first instruction, and we're going to change the device name to C1V0 and apply. We're going to duplicate that. We're going to change the name. So now we're setting it up for CPU 2 V0. Apply that one. Duplicate it again. Set it up for CPU 3. And apply. Now we're going to set up the second VPEs. So we're just going to duplicate one of these. So C0V1 is the first one. We're going to set this up a little differently. We're going to say we debug boot code. We'll leave everything else the same. And we're going to set it up to C0V1. We're going to duplicate that one, and so on. Okay, so now that we have all of them set up, I set up the other two. We're going to actually start debugging with C0V0. We're going to hit debug down here, and we will watch the messages go by. So one of the things while this is coming up is the FPGAs are set up that when you have these probes attached, only the first CPU actually is powered up. So as we did in the boot code, we brought up the first CPU and then we actually powered up using the software to power up the remaining CPUs. So we have to kind of do this in a specific order. We can't start debugging a CPU if it hasn't been powered up. So we're going to have to actually run CPU 0 to a certain point before we can power up CPU 1 and CPU 2 and CPU 3. Okay, so we actually have booted the first CPU. Now we don't really see a whole lot here. So what we want to really do is we want to show a disassembly view, and we can actually see some of our code. Now the reason why we can't see in the source view the source of this yet is because we actually compiled this code for a 9FC0000, and it will always boot at BFC0000. So this is in KSEG 1, and we built the code for KSEG 0. And we did that because it makes it easier to switch to cache mode. So what we have to do is we have to actually do a few steps before we're going to see this. And once we do this JR, it'll actually jump to a 9FC address. Okay, so now that we're ready to start doing some stepping, we'll make sure that we're in instruction step mode, and we're going to step a few instructions, and then we'll end up seeing the source code in the source code window once we do the jump. Okay, so now we're at the point where we can debug. We can step through all this code as we want. We can move ahead and set a breakpoint. For example, let's move ahead here, and we're going to set a breakpoint at init GPR. We got to set a hardware breakpoint. So why do we have to set a hardware breakpoint? Well, because we're operating in a flash RAM. and we can't actually write to that flash RAM. And the way debuggers do breakpoints, they actually write over the instruction that's there after they copy it somewhere. So they hit a breakpoint. When they hit the breakpoint, they rewrite that instruction back. So we can't do that in Flash. So we're going to use the hardware breakpoints of the CPU to actually break. Now, we don't normally use the hardware breakpoints because there usually aren't that many of them. But in this case, we know we're only going to set a few of them. So we can do that, and we can run to the breakpoint. And we see we hit the breakpoint. We can do things like examine registers. Open up our register window a little bit more. Things like that. Okay. At this point, I'm going to clear this breakpoint actually. Toggle it off. Okay. So now what I'm going to do is I'm actually going to bring up a additional view which will help us with seeing what's going on with the other CPUs. Okay, so it's the device status view. And we're going to open this up a little bit. I think we'll actually get rid of this since I don't have a whole lot of real estate in this recording. And we see we have a nice graphical display now of all of our cores and each VPE. So we see we are running just the first one. All the rest of them are halted. So I want to run the first one ahead, and I'm going to run the first one ahead to the point where it's going to start powering up the other cores. And we can pause it, and we can see it's in this busy wait loop waiting for the other cores to catch up to where it's at and synchronize. So I'm going to start the other cores. Now what I'm going to do is I'm going to start the actual cores first, and then I'm going to start the second VPE. So we're going to go to C1 V0, and we're going to hit debug. And we'll wait for that one to come up. Let's take a look. We see it's suspended. And we see that it says BootMIPS here. So now we're going to go and start up C2 V0. Watch that one come up right here. And we see that we now have that. I guess I'll just open this up like this. And we're going to start up C3 V0. So we're going back up, look at the dialog. C3 V0, C3 V0, hit the debug. And we see that it is up. Now we're going to run the cores. Start each core. C1 V0, C2 V0, and C3 V0. And all of these are actually going to be running, and they'll end up somewhere in the main program. And now we're at a point where we can start the VPE1s of each one of the cores. So we're going to do that. Go up to the dialog. C0 V1. C1 V1, C2 V1, and last C3 V1. For a minute, let's take a look up in this window, and we can see we have C3 V1, we have C2 V1, we have C1 V1, and we have C0 V1. So at this point, if we look at the board, we can see the 3 R's for the CPUs that are ready to run. So here I've halted C2V0, and we can see where it's halted, but this is actually where the R got displayed on the display. So at this point, what I'm going to do is I'm just going to start them all going. And what we're going to see on the display is a bunch of blinky numbers. Okay, so if I stopped any one of these, you're going to see that it's in this while loop, and it's displaying the CPU number, its own CPU number on the segmented display on the multiboard. And what it does is in these 2 for loops, it displays the number, then in the other loop it actually clears the number, as you can see here. And here on the multiboard you can see the numbers blinking for each CPU.